We start with problems on definite integrals. Note that integral is nothing but area under the curve. So given this graph, the rate of change in air temperature at a certain place is recorded through the day. If the air temperature is observed to be 60 degree Fahrenheit at 5 a.m., what will be the temperature at 8 a.m.? So basically we have to calculate the area of the curve from 5 to 8 a.m. So that will be 60. Now already it is 60 at 5 a.m. So it is 60, and from 5 to 7 it is going down. So this triangle is actually having base 2 and height h. So it will be minus half 2 into 2, and the other triangle has base 1 and height 1. So it will be half 1 into 1, and this will be plus because it's on top. So the temperature will be 58.5 degrees. Oil is leaking from a can at a rate of Ft equal to 12 e raised to minus 0.4 T ounces per hour, where T is measured in hours. After 12 hours, how many ounces would have leaked from the can? So we use the graphing calculator here. So it will be integral 0 to 12, 12 e raised to minus 0.4 T dt, which will be 29.753 ounces. Again, you're given a graph. Water is leaking from a tank at a rate of Ft, and the graph of F dash T is shown. What is the total amount of water leaked from the tank for 5T varying from 5 to 10? So you can see here. So total amount of water which can be leaked can be approximated using area of this trapezium. So the big height is 30, 0 to 30. The small height is 5, and the width is again 5 to 10. So what is the formula for area of a trapezium? Half capital B plus small b into height by 2. So that would be 88. Now, between the months of February and July, the sales increase at a rate which can be approximated by f dash t equal to 30 plus 20 log 1 plus t, where t is measured in weeks. There were no sales in January, so what will be the sales by the end of the 7th week? So that would be integral 0 to 7 f dash t, that is 30 plus 20 log 1 plus t dt. Again, using the calculator, you get it as 402.71. So approximately the sales would be 403 by the end of the 7th week.